Hi everybody, welcome back to the Feynman technique. This is going to be the first video in a series titled Things We Take for Granted. This is going to be number 1. And the thing we're taking for granted in this video is the fact that, or what we have been taking for granted is that the derivative with respect to theta of sine theta is equal to cosine theta. And also that the derivative with respect to cosine theta is equal to negative sine theta. We're going to be doing the visual method. I like it better. It's my favorite derivation of this. So it starts with the unit circle. So this is the unit circle, has a radius of 1. We construct a right triangle from this with angle equal to theta. So we can see we have this right triangle, we'll have angle theta. Therefore, this angle right here is pi over 2 minus theta. This indicates a right angle. And of course, if this is the unit circle, then this length right here will be equal to cosine theta. And this length right here will be equal to sine theta. All right, now what we have here is a change in the angle. Basically, we're making a change in the angle. Because that's what derivatives are. It involves changes. So this is labeled delta theta, indicating a minuscule, infinitesimal change in our angle theta. Of course, we're going to magnify it. We're zooming way, way in. So this is not to scale at all. This is actually a very, very small change. And what we do is this line right here is actually the tangent to the unit circle at that point of intersection right there. So it's a line that's perpendicular to this hypotenuse right here. So yeah, but again, it's zoomed way, way in. And if you zoom in on a circle enough, it becomes very, very close to a straight line. And that is the zoomed in curve right here. This is the actual curve. This is what it looks like when you zoom way, way in. And always remember this is zoomed way in. This is a very small change in theta. Okay, so where does the rest of the stuff that I have labeled come from? Well, if this line right here is perpendicular to this one, they form a right angle. And I specifically chose this line to be perpendicular to this one. So this is a right angle right here. And if this is a right angle, then this has to be theta, because this is pi over 2 minus theta. And if you add those two things together, you'll get pi over 2, which is a right angle. All right, so we have theta, pi over 2 minus theta, and this is theta. All right, and this triangle is just constructed. It's just constructed. This is the hypotenuse. Our delta theta right here is the hypotenuse. This is just a line that is perpendicular to the opposite side of this triangle. So it just goes straight out like this. And this is a line perpendicular, I'm sorry, not perpendicular, it is, well, yeah, perpendicular to this line that intersects where this line intersects there. Okay, so you get the idea, you get how that triangle was constructed. All right, I hope so. Rewind the video if you don't. So, since we have a right angle here, if this is theta, then this is pi over 2 minus theta. And if this is a right angle, and this is pi over 2 minus theta, then this must be theta. Okay, so now we have two congruent right triangles. Congruent meaning they're just zoomed in versions of themselves, zoomed in or out. Okay, so what was our original goal? Our original goal was to show that the derivative with respect to theta of sine theta is equal to cosine theta. Well, what is this? What is d theta sine theta? It comes from this. It comes from the ratio, a change in sine theta over a change in theta, right? That's where that notation comes from. delta sine theta over delta theta. Okay, well, something I didn't explain before is if this line right here indicates a very small change in our angle theta, this is delta theta. What's this? Or I'm sorry, we'll start with this. What is this? We have an arrow right here. This represents a change in sine theta because with respect to this right triangle right here, this is our angle theta. This line right here represents a change in our sine theta. Do you see that? So this is delta sine theta. Okay, well, what's this? Now this line right here was a stumbling block for me for a long time. And by the way, I got this derivation off of the channel. I think it's 3 Blue 1 Brown. Probably my favorite math YouTuber ever. Yeah, where was I? Okay, yeah, this is the stumbling block right here. This is where a lot of people struggle with this proof. Okay, what is this? Well, it is a change in our cosine theta, yeah. But don't forget, if our angle is going this way, what's happening to sine theta? It's increasing, but what's happening to cosine theta? It's decreasing. So this is actually negative delta cosine theta. And that's a huge stumbling block. You have to realize that this is a positive change, or positive delta theta, and this is a negative delta cosine theta. Okay, so now let's just find out what this is. What is delta sine theta divided by delta theta? Well, where's our delta sine theta? It's right here. And that is the adjacent side to our angle theta. It is the adjacent over the hypotenuse. What is the adjacent over the hypotenuse? It's cosine theta, okay? This over this. Don't forget, we have to rotate that triangle because this is actually our theta. This is not our theta. This is pi over 2 minus theta. So don't go thinking that sine theta is this over this. Well, actually it is. Sine, yeah, okay, I'm sorry. So yeah, delta sine theta, right here, we've already said that this is delta sine theta, over delta theta is this over this. In other words, it's cosine theta, because with respect to this angle, this is the adjacent side. So adjacent over hypotenuse is cosine theta. So do you understand? I hope so. I'll rewind the video again. If you don't, I think I explained that pretty well. And likewise, dd theta cosine theta equals negative sine theta. We'll show that real quick. This is equal to cosine theta. And then, of course, delta cosine theta over delta theta, which would translate to dd theta cosine theta. That's going to be equal to this ratio. Well, what is that? Well, we know that negative delta cosine theta over delta theta is equal to this over this. That is sine theta. Multiply both sides by -1 and you get this. So that's it. There's the visual proof of why the derivative of sine theta is equal to cosine theta and why the derivative of cosine theta is equal to negative sine theta. There you go. There's my first things we take for granted video. There'll be more coming soon. Hope you enjoyed that.